So first, the customer demand. Always start with customer demand. What is the customer demand in our case? Let's start writing. So we'll start with the customer demand. Then we should see the available time. Customer demand varies depending upon the type of nature of business, number one, the seasonality of the product, and so on and so forth. So customer demand may not be as straightforward as it is. For example, made to order type of item is there, made to stock type of items, where we see the market consumption and then we start manufacturing based on that. Or the customer seasonality, yeah, umbrella, raincoat, fantastic. Even this fan, right? AC, air conditions. Okay, fruits is availability. Yeah, cool drinks, cooler. Okay, these are all seasonality type of products. And so you must know the customer demand. The biggest challenge in customer demand is what is the duration based on which we would have to take the customer demand. What, for example, if my yearly requirement was so and so, last year requirement was so and so, this year, can I say my average monthly requirement is so and so? Is it the right way of saying? Suppose last year I have sold 1,200 pieces. This year, can I forecast that it can be 100 pieces a month? No, it is wrong. Even in last year's trend, we'll have to see which month we have sold more, which month we have sold high, to find out the seasonality of the customer demand or customer consumption. We need to see the seasonality also. So the point that I'm trying to say here is, here the customer demand in this month has been given as 12,000 pieces plus 6,400 pieces. One is left-hand drive for left-hand drive and one is for the right-hand drive. So we are taking 18,400 pieces like this. The customer demand will not be as straightforward as that. So this is the type of challenge that you will face in real life, but there is a way to handle it. Available time. Available time, very important. We need to remove all the, planned time. Remove all planned time. Let us call it as planned time. There are different types of times and the definitions in books are different, but we will calibrate to what is written in this Learning to See book. So remove all planned time. And what is planned time definition? Coffee break, shift time. Yeah, planned time. Let's call it as planned downtime. Which are all the planned downtime? Remove the planned downtime. Planned time is a wrong way of writing downtime. Planned downtime will have first holidays, which includes scheduled holidays as well as weekend holidays. Next, non-working shift. For example, you might work for 5 days, but only on 2 shifts. So shifts, okay, holidays, the shifts which are not working. Then comes lunchtime. Then comes tea or coffee break. And then planned maintenance. Planned maintenance, that is preventive maintenance. That is planned, not the breakdown maintenance, but the preventive maintenance. So some examples I've given, which means it's a management decision. It's a management decision. The reason that I'm saying is when you calculate the available time, please remove all the planned downtime. That's the point that I was trying to make. If this is clear, the balance time is the available time. We are not talking about a value added time here. Okay, I'll clarify the touch time later. So now, as far as the customer demand is concerned, there is a straightforward which says 12,000 plus 6,400. So 18,000. Now they said that they work for 20 days. So per day, 920 pieces and 460 pieces are required. Whereas if you see the total shifts that are, they said it's a 2-shift operation. So per shift, if you see here, 8 hours into 3,600, which is 28,800. And there were some 20-minute breaks, which is 1,200 seconds. So the available time was 27,600. So this is the available time. So this one is the customer demand and this is the available time. The reason that this same 27,000 I've just broken just for your understanding, because in the example it is given, there is a 20-minute break is given, an 8-hour shift is given, and I've just calculated something for you here. Once we know that it is 460 pieces required per shift or 920 pieces required per day, we calculate the takt time. Takt time is nothing but the available time divided by the customer demand. You can put the customer demand per day is 960 also, and you can put 27,600 per shift into 2 also, or I have just calculated 460 per shift and 27,600 seconds that is available in a shift, and hence the takt time is 60 seconds. If the takt time is clear, I've explained the same thing in the previous sessions also in detail, but I'm a little bit going fast here because it is already explained in the video. And if you see most of my videos, I don't rush things. Whatever that we have done in the previous session, at least 10 to 15 minutes we will recap, and then we will continue the next session. And that is always my style of training. So coming back to the various places where we have inventory, we said at various stations we have this inventory. Yes, welding 1, 2, assembly 1, 2, and shipping. And we have 7,000 pieces, 1,700 and so far, up to 4140. And the 7,000 is 4,600 plus 2,400. And all this data is given in the case study on the book Learning to See. Now, we said 920 pieces per day. We had explained in length in the last session why we take customer demand to calculate inventory into lead time, inventory into time. The time in this case is number of days. The unit of time is number of days in this case. The reason that we use the customer demand is because even if you produce fast, irrespective of whether we produce fast or slow, the consumption pattern is decided by the customer. And that is why the customer demand is used to. This is one of the most important understanding required in a value stream mapping. If that is clear, inventory between the process is confusing. There is nothing, I mean, this is the data that is seen in the workplace. This is the data that is seen in the workplace. So what you see, they have written. What you see, I walk through the factory, I see how much of pieces are there, and I've written the pieces. The only thing that could be confusing, I've seen a lot of exchanges in WhatsApp, and I think the direction of thinking was correct. I mean, tomorrow this inventory can become zero also. And that is why I said, this inventory is nothing but a snapshot at that. It's like taking a photograph. I always say snapshot, okay? If you take a photograph, maybe in the next second when the players are playing in the field, you take a picture. Next second you take a picture, the players will be in different places. If you watch the game of cricket. So it may not be the same inventory and same time. But one thing we have to understand is, when we are talking about 7.6 days of inventory, now we start discussing that here we have 7.6. That is why in value stream mapping, we said this is a subject matter experts discussion, and not any TDH should come and discuss. What is TDH? Tom, Dick, and Harry. It is just, for example, if it is 7.6 days of inventory is what the team has observed and put it in the map, the natural question is, should we have a project to have only 3 days of inventory? That is the natural question. The natural question should be, can we cut this inventory by half? Suppose if the team says, no, whatever 7 days of inventory that is projected here is very abnormal situation. Normally we keep only 3 days of inventory. Then you can put 3 here, no problem. But then change it to 3 only after validating with the data. You can say observed inventory is in so and so. You can add another column. This is based on data, you can say this inventory is generally 3,000 and not. You can arrive at that and then take a decision. Am I clear about this? So you can have another column here which says, though this snapshot shows it is 7,000, but generally if you see the past data, in general, the inventory might be only 3,000. This can be an exceptional situation. So see the data. Suppose if the data has got a lot of variation. Sometimes it is 1,000, sometimes it is 10,000. Today it was 7,000. Sometimes it is 0. Sometimes it is now. Then you should take a project definitely, because we need to first, the objective is not, all of you, if you're having notes, please write these notes. The objective is not to reduce the inventory in the beginning, but to reduce the variation of inventory. The objective is not to reduce the inventory, but to reduce the variation in inventory. Which means, suppose if you see the past data and if it varies between somewhere between 2,000 to 12,000, and today you see 7,000, the objective is not to reduce that 7,000. The objective is to, instead of 2,000 to 12,000, try to reduce the variation. Let it be between 5,000 to 9,000. So if it is clear, I'll move on to next. Thanks for that. So now this snapshot, the team has agreed that this is a representative inventory. What we have seen today is mostly the representative inventory. If it is not the representative inventory, we can see the past data and populate it here. But the point here is we need to see how many days of inventory that is there. We see that it is 23.6 days of inventory. What does it mean? It means that any new bracket that I have to manufacture, it has to pass through, assuming that the manufacturing has happened first in and first out. This has to, imagine this as an airport. In airport, I have always observed in 4 places, you have to stand in the queue. First, when you enter the airport. Second, if you have to get the boarding card. Third, the security check. The fourth is probably in the bus, and fifth is inside the flight. Assuming everything goes first in, first out, if you are the person who is entering in the airport, it all depends upon how many people are in front of you. Similarly, if so many people are there, okay, they have to go through the entire process before they can board into the. So that is why it will ideally take 23.6 days. Suppose if you are a VIP, you might catch a charter flight. Suppose if you are a VIP, certain people can avoid the security check also. So we are not talking about that here. So with that understanding, if you are having 23.6 days, the value added time is only 188 seconds. If there is no inventory, then everything will come out in 188 seconds, assuming there are no wastages in between. Okay. Is it possible to do it in 188 seconds against 23.6 days? Impossible. We know that. But is it possible to do it in 10 days? Definitely, it is possible. So the best way to do is, instead of reducing the cycle times and working on cycle time projects, it is better to see how much we can actually work with less inventory. When you want to work with less inventory, automatically in Lean, you will find out inventories are actually necessary for various reasons. One of the reasons why inventory is necessary is because of the distances between the processes. Because of the distances between the processes, you need a lot of inventory, which means there'll start to be 2 storage points. If the process is next to each other, there can be 1 storage point. So inventory, 1 bin here, 1 bin there. Instead of that, if the processes are closer, there can be only 1 bin. This is just one example. So the distances and also the rejections. If rejections are more, we tend to plan for more and produce more inventory. And so on and so forth. If the setup time is more, we tend to produce more inventory. If setup times are more. Suppose if there is a big sheet of metal and we have to blank some components from that metal. Suppose we need to use only a few pieces from there. The setting time of that, let's say it's a profile cutting machine. For non-manufacturing people, please pardon me. Profile cutting is nothing but we all know through welding we can cut, right? So similarly, some with flames you can cut. Okay. Now, if you're cutting the sheet of metal, there is a program that is written there and it will cut the blanks. Now, the sheets come in standard size, some 1200 mm by 3000 mm, something like that. If you have to actually, for a particular product, if you need only 2 or 3 small pieces cut out of that, it will become very difficult. You have to cut the entire sheet because setup time itself is very high. The technology has a limitation in cutting small pieces, or even the supplier has a limitation in giving small sheets. It may not be either commercially viable or practically not possible to give. So similarly, the point that I'm trying to say is, I will also give you the reasons why inventory is accumulating. You can also please put in your in the group as why we generally, what are the conditions which is limiting us from reducing the batch size? What are the conditions which are, suppose if you have big oven in which biscuits are baked, do you think if the order is only for 10 biscuits, for 10 biscuits you will put it in the oven where 100 biscuits can be made? No. So what we will do, anyway the biscuit order will come against a 10 pieces order. Let me make 100 pieces and keep, and I'll sell 100 pieces later. Is it a bad decision? Depends. In the current circumstances, we have no options. But if you apply lean thinking, you may get some options. With that, I will just stop this discussion and go forward. Because this particular point should be very clear that we have to look at options. Two thinking process should be very clear. One is, if you reduce inventory, the flow will enhance. You can produce in shorter lead times. That thinking process should be clear. The second is, one is it possible to drastically reduce inventory? Not always. But is it possible to some extent reduce inventory? It is possible. But while doing that, some other constraint will come up. You will have to overcome that constraint. The constraint might be something like distances. The constraint might be something like the setup time. Constraint might be something like the machine efficiencies, etc., etc. The U curve, we said, the amount of inventory versus management attention. Amount of inventory on the x-axis and the management attention on the y-axis. Now, we said that if the inventory is very less also, it catches management attention. If the inventory is much higher also, it catches the management attention. The best point is to start somewhere in between. That's what we have discussed. Now, if you see the theory of constraint, I will confuse you a little bit deliberately, but with the confusion, you will get clarity, okay? In theory of constraints, what Dr. Goldratt is proposing is, the bottleneck process is what actually decides the output of the entire system. Because bottleneck process decides the output of entire system, do not waste any time in the bottleneck. Let me repeat it. If there are 10 processes, process A, B, C, D, E, F, G, H, I, J, if there are 10 processes, so if the process E is the bottleneck and the cycle time in process E is highest, and that decides the output of the entire system, make sure that bottleneck process works with maximum efficiency, preferably 100% efficiency. Every efficiency drop in the bottleneck will amount to efficiency drop in the entire system. I will add something to this because Maninder prompted, depends upon the cost of inventory versus the profit. And the answer is right thinking. Before the bottleneck, you can keep maximum inventory possible. Inventory before the bottleneck is okay. The reason is, even for a second, bottleneck should not start because there is no material. But make sure whatever inventory that we keep before the bottleneck is 100% quality verified, because we don't want any quality issues to actually go to bottleneck and spoil and waste our time. make sure before at the bottleneck, the manpower is highly skilled, so that unskilled manpower should not consume the bottleneck operations time. As I say, you can keep typing these rules, okay? First, rule number 1, keep sufficient inventory. Rule number 2, make sure the quality is 100% okay of the material that is fed to bottleneck, so that because of the material issues, bottleneck time should not be wasted. That is rule number 2. Rule number 3, make sure that the manpower that is used in the bottleneck is highly skilled, because unskilled manpower should not waste the time of the bottleneck. Rule number 4, make sure machines in the bottleneck are maintained pakka, that is maintained to 100% as per preventive maintenance, so that it doesn't starve the time because of some breakdowns. And even if it is by mistake there is a breakdown, because machines tend to break down, Murphy always says, that's what Dr. Goldred says, even if it is a breakdown, maintenance should give the maximum preference and priority to the bottleneck. Even if he's doing some urgent work, he should drop and come to the bottleneck, because any minute, not even a single minute, should be wasted in the bottleneck. And the production scheduling should always be done at the bottleneck. In Lean, we are going to talk about Haijunka, the production scheduling, and you schedule everything at the bottleneck. After bottleneck, everything should go first in, first out. All right. So how many of you found this information useful? Please type useful if you have understood it. Useful, valuable, informative, and all that. At some point in time, I'll get into the Lean and the theory of constraints sometimes. Okay. So you need not go for single piece flow always. Okay. You need not go for single piece flow. Though I'm called the Lean Murali, okay, I don't propose single piece flow. Please understand that. I don't propose single piece flow. You have to use the combination of Lean Six Sigma, TOC and Kaizen. Lean Six Sigma, TOC and Kaizen. Theory of constraints helps us to find out what to improve. The Lean tools gives us how to improve from the waste reduction point of view. The Six Sigma tools help us how to improve from the variation reduction point of view, and Kaizen tools helps us to develop our team, to build a culture. Okay, so all these tools are very useful, but we need to put these pieces of puzzle in the right context, so that we can achieve the strategic objectives of the organization. All right, so with that, we, in the value stream mapping, we question and say, okay, if there's 5 days of inventory, we challenge and say, can we have 4 days of inventory? If it is 7.6 days of inventory, we challenge and say, okay, can we have 3 days? So we discuss with the team, and then we challenge and say, and said we'll have a separate project. Now, when we want to reduce, when we actually try to reduce this, team will come out with various challenges. They will say, provided you give me a welding machine, I'll be able to do this. Provided you give me this, provided you give me that support, this support, and things like that. That is where, provided maintenance, repairs my machine, and we've been asking for spare parts for a long time. So if we can up this, etc., etc. So that is the project that we will, ultimately the objective of the project is to make sure that we have only this inventory. When you reduce the inventory, then you will know what are the inefficiencies that actually prevents people from maintaining that inventory. For example, batch sizes will prevent people from maintaining that inventory, or supplier limitations can prevent people from maintaining that reduced inventory. And that is where we'll have to work on projects, realistic projects, so that we continuously improve our throughput time.